Excessive privileges or capabilities vulnerabilities occur when infrastructure produced by templates is not configured according to the principle of least privilege. The principle of least privilege states that each entity should only be granted the minimum amount of permissions that allows executing legitimate functionality, while excessive privileges or capabilities are not directly exploitable. Granting excessive permissions makes the potential impact of compromise worse. Some common examples of excessive privileges or capabilities in the context of infrastructure as code templates include running containers as root, sharing the host network with containers, and creating user accounts with administrative privileges. Preventing this issue requires careful analysis of all components of your infrastructure and only assigning to users and components the least privileges necessary for the infrastructure to function correctly. Creating infrastructure declaratively can result in transport layer security (TLS) misconfiguration errors, such as missing or invalid certificates or using unencrypted connections when TLS tunnels are readily available. Assurance provided by TLS also depends on using strong cipher suites, but these are not typically specified in templates. It may be acceptable to use another cryptographic solution for protecting data in transit besides TLS, but TLS is the industry standard used for this purpose and is used by all major cloud service providers. Some of the security assurances provided by TLS require the use of valid certificates which help prevent man-in-the-middle attacks. TLS certificates that are used by the infrastructure will often have to be configured using the templates. If the templates do not configure valid certificates, then TLS misconfiguration errors will result. Sensitive data in transit should be protected using encryption, which is usually accomplished by using TLS, but common misconfiguration errors can result in using unencrypted connections instead of TLS tunnels. A common example of this issue is using HTTP instead of HTTPS to transfer sensitive data. When doing so, TLS is simply not used at all, and data is sent over the network unencrypted. When configuring your infrastructure, make sure to use TLS to protect sensitive data in transit and to use valid certificates with TLS. Misconfigured network filtering occurs when either inbound or outbound network traffic is not sufficiently restricted to protect the infrastructure. If inbound traffic is not sufficiently restricted, then internal services or applications will be exposed to external attackers. If outbound traffic is not sufficiently restricted, then an attacker will be able to easily exfiltrate data in the event of compromise. Default configurations often impose no restrictions on network access at all. The most common and most dangerous types of misconfigured network filtering occur when inbound network traffic is not sufficiently restricted and internal administrative services or custom applications are exposed to public networks. For example, network filtering is often misconfigured to allow Internet access to Secure Shell (SSH) services. SSH services are typically used for system management. An attacker gaining SSH access to a production system is a disaster. Gaining SSH access to a system is extremely valuable to attackers, and brute force SSH attacks on the Internet are very easy to execute. So all SSH services exposed to the Internet on standard ports are continuously subjected to dictionary attacks. While using a non-standard port for accessing SSH from the Internet does reduce automated attack volume, it will not prevent a targeted attack. The real solution is to use network filtering to block access to SSH services from public networks. This principle applies to other services that are commonly used for system management, such as Remote Desktop Protocol, RDP, and Virtual Network Computing, VNC, though in a DevSecOps environment, the most commonly used service will be SSH. Nonetheless, in some real-world scenarios, network filtering is still incorrectly configured to allow all inbound traffic, which allows attackers to attempt to exploit all systems, services, and applications that are running on the exposed network. Network filtering should be configured to deny all traffic by default, and then use individual rules to only allow authorized traffic, both inbound and outbound. It is not only system management services that are at risk of external attack. The more services and applications are exposed to the Internet, the greater the overall attack surface, and the more opportunities are presented for attackers to cause harm. Unless an application is intended to be accessible by the general public, there should not be a rule that allows Internet traffic destined for that application. Outbound traffic should also be restricted to prevent attackers from exfiltrating data. Rules that allow outbound traffic should only exist for applications or services that need Internet access. The general solution for accessing system management services and internal applications is to allow access only for users that connect to the virtual network using an authenticated VPN service. But the actual specifics of implementing your infrastructure should be guided by your organization's policies. In this example, all external access to a secure shell (SSH) service is allowed, making it possible for attackers to continuously attempt to guess SSH credentials. Click inside the code window to see the mitigation. In this example, all outside network access is blocked by default. Access to any network services will need to be enabled with individual rules that sufficiently restrict access to minimize attack surface. Missing encryption commonly occurs when cloud storage is provisioned without encryption enabled. Cloud storage encryption is typically used for compliance reasons. Some of the most popular container types work essentially the same from the perspective of the application or the user, whether server-side encryption is enabled or not. Server-side storage encryption is intended to protect sensitive data if the cloud service provider is compromised, but if it's transparent to the user, then it will not protect your data if your application is compromised. That said, server-side storage encryption is typically sufficient to meet compliance requirements. You should enable encryption for storage provisioned by your infrastructure as code templates according to your organization's policies. If transparent encryption of data at rest is not sufficient, then your application will need to implement additional encryption functionality, which is a task that cannot be accomplished by infrastructure as code templates alone. For most common scenarios, however, it is sufficient to simply enable encryption options for storage created by templates. In this example, a simple storage service, S3 bucket, is created with default settings, which do not enable server-side encryption. Click inside the code window to see the mitigation. In this example, an S3 bucket is transparently encrypted on the server side using the Advanced Encryption Standard, AES algorithm, with 256-bit keys. This encryption will protect the data in the bucket at rest. Exposed storage vulnerabilities occur when infrastructure as code templates create cloud storage containers or backups that are accessible to the public, usually to the entire Internet. Some common examples of exposed storage are creating public S3 buckets and Relational Database Service, RDS snapshots. Other types of cloud storage and backups would also be examples of this vulnerability type. Whenever your templates create cloud storage or backups, the appropriate access controls should be configured to allow only authorized access. In this example, an S3 bucket is created that allows its contents to be read by anyone on the Internet. This bucket is not suitable for storing sensitive information. Choose from the two options to provide a mitigation. This example adds access control restrictions to the encrypted bucket from the earlier missing encryption example. This access control setting grants full access to the owner of the bucket and does not grant any access to anyone else. Missing logging vulnerabilities occur when logging functionality is disabled for infrastructure that is created from infrastructure as code templates. Some common examples are disabling access logging for S3 buckets and disabling the RDS event subscription for database security groups. You should enable the logging functions that are provided by the technologies that you are using and that are appropriate for your organization's infrastructure monitoring processes. Generally speaking, cloud service providers will provide logging features, and you should always enable them, because the cloud service provider will store the logs for you, and you can process these logs whenever you need them. Possible exceptions to this rule would include situations where cloud service provider logs might exceed data retention requirements or include sensitive information, but these situations should rarely occur in practice. IaaC best practices include following policies and industry standards, following the DevSecOps processes, scanning IaaC templates on commit, and monitoring cloud infrastructure. Click each best practice to learn more and then continue. Follow the organization's existing policies, refer to functional requirements, and consult additional applicable standards or compliance requirements. Adapt the automated security activities of DevSecOps, such as testing and vulnerability scanning, to plain text IaaC templates. Additional specialized tools may be required. Scan IaaC templates for vulnerabilities when committing them to code repositories to detect issues in templates before they cause any actual exploitable vulnerabilities in provisioned or managed infrastructure. Monitor infrastructure for signs of compromise, such as spikes in resource usage or unusual access patterns, to help detect, respond to, and minimize the impact of successful attacks. You have successfully reviewed infrastructure as code and the best practices surrounding this implementation. You now have the skills to convert requirements into source code and identify and mitigate common vulnerabilities.